Hey everyone, we're gonna do part C. It says it's a bonus. We'll do it graphically. And I'll do it in Desmos. You can certainly do this in your graphing calculator, but I think it's much easier to do in Desmos just for fun here. So y equals 2 sine of x, 2 sine of 2x. I'm doing part C, the bonus part. So y equals 2 sine of 2x, there it is. And I'm going to make it intersect y equals -1. And then I'm going to pick the intersection point. So there's one. Let's label that. There's the second one. There's the third one. And it's, remember, we're defining the domain as in between 0 and 2 pi, not including 0 and 2 pi. Okay, so your four solutions are 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. That's part C, number 1. Let's do number 2. Okay, so I'm going to clear all this. Okay, cosine of 2x equals 1. So y equals cosine 2x, and I'm going to make it equal to 1. Ooh, -1. Okay, and then let's define this within the same domain, 0 to 2 pi, and here are my intersection points. Um, 2 pi, so this is beyond there. So your solutions are pi over 2 and 3 pi over 2. Okay, number 3. We have tangent squared of 2x. Y equals tangent squared of 2x, and y equals 3. Let me increase my, there we go. Just adjusting my window on my graph. So what do I got here? So within the domain, so we got a bunch of solutions for this one. I have pi over 6. I have pi over 3. I have 2 pi over 3. Let's label that. I have 5 pi over 6. So it looks like I have a solution. Yeah, pi over 6. One of the solutions varies by pi over 6. The other one, sorry. Yeah. No, one of the solutions varies by pi over 2, because I'm going from 2 pi over 6. Yeah, pi over 4 pi, 2 pi over 3, sorry, yeah. Oh man, gotta be careful reading these. Okay, label that. Label that. All the way up to 2 pi. This is the last solution, all the way up to 2 pi, but not including 2 pi. Okay, so this is number 3, which is tangent squared of x. I have solutions of pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. Okay, and that checks out. Okay, next one, folks. I have 2 sine squared, 2 sine squared of 2x, 2 sine squared of 2x, 2 sine squared of 2x minus 1, and y equals 0. And this has got a bunch of solutions. So pi over 8, three pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and then the last one just before 2 pi, 15 pi over 8. So let's go over this again. Pi over 8, 3 pi over 8, 5, so pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. Lots of solutions there. Okay, on to number 5. I have y equals sine of 2x times cosine of 2x. Let me throw some brackets around there. It's not recognizing it. Sine of 2x times cosine of 2x. Okay, there it is. Okay, and that's y equals 0. Okay, so I'm not going to count that one because that is not in my domain. So the next one over, that's pi over 4. Pi over 2. Three pi over 4. Pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. And this one I'm not going to count because it's right on 2 pi. So I have pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Okay, number 6, y equals cotangent squared of 2x. Well, I'm going to use the trig identity. So it's 1 divided by tangent squared, tangent squared of 2x. That's the left side. Okay, and then the right side is y equals, well, cotangent of 2x, I'm going to do 1 divided by tangent of 2x. Okay, so there's our two graphs, left side, right side. Where do they intersect? That is our solution. So let's start looking here. So that's one of them. So pi over 8. Here's another one, pi over 4. Okay, and then we're repeating here. Pi over 8. 3 pi over 4. 9 pi over 8, 5 pi over 4, 13 pi over 8, 7 pi over 4, and that's as far as I'm going to go because I'm up to my limit here on 2 pi. So pi over 8, pi over 4, 3 pi over 4, 5 pi over 8, 5 pi over 4, 9 pi over 8, 13 pi over 8, 7 pi over 4. Pi over 8, pi over 4, 5 pi over 8, yep, there it is, 3 pi over 4, 9 pi over 8, 5 pi over 4, 13 pi over 8, and 7 pi over 4. All right, that's number 6. Let's go to number 7. Okay, so number 7. Number 7, on the left side, let's just put all of that quadratic on the left side. So 2 sine squared of 3x minus sine of 3x minus 1. So 2 sine squared of 3x minus 3 sine of 3x minus 1 equals 0. And then, of course, y equals 0 will be our other line. And where do they intersect up to 2 pi? So I have pi over 6 right there. What is that? 7 pi over 18. Awesome. What's this one? 11 pi over 18. Awesome. Next one, I have 5 pi over 6. Good. Next one, 19 pi over 18. Let's label all these. Sorry about that. Okay, next one, 23 pi over 18. 3 pi over 2. 31 pi over 18. And just before the 2 pi limit there, 35 pi over 18. So let's label all these and then let's take a look. Okay, all labeled. And let's take a look. Number 7, pi over 6, 7 pi over 18, 11 pi over 18, 5 pi over 6, 19 pi over 18, 23 pi over 18, 3 pi over 2, 31 pi over 18, 35 pi over 18. Good, got them all. Let's go to number 8. Okay, number 8, I have y equals 2 sine squared of 1/2 x 1/2 x minus 1, and then that's y equals 0. All right, where do they intersect? Pi over 2. Another one here at 3 pi over 2. Okay, and then this one is outside of our domain. So I have 2 solutions, pi over 2 and 3 pi over 2. Bingo, there we go. All right. Next one, I have y equals, all the left side is 1 minus tangent of 1/2 x. Okay, so 1 minus tangent of 1/2 x. And then the right side is y equals 0. All right, what do we got here within our domain? I have one intersection point, and then this one is outside the intersection point. So my solution here is just one solution, pi over 2. There we go. And the last one, number 10. I have cotangent of 2x, so I'm going to use the reciprocal tangent of 2x. So 1 divided by tangent of 2x, that's the left side, folks. And then the right side is y equals, I need the square root of 3. All right, and then let's see where they intersect. I have pi over 12. I have 7 pi over 12. I have 13 pi over 12. Let me label those. Okay, good so far. And then looks like one more. 19 pi over 12. Okay, so that I have pi over 12, 7 pi over 12, 13 pi over 12, 19 pi over 12. That's it, part C.